Hey, welcome back. I'm just checking our connection, make sure we're ready to go, and check sound. Looking good. Cool. All right, so I was looking at this first reading on catching things in motion, so trying to get some data from videos, and you can do it from images or anything. And there are like more advanced ways of cross correlation methods with images to track, like doing image tracking. This one's kind of the bare minimum of just like converting pixels into actual measurements. So let's take a look at running this and see how we can go from one to the next. So we're going to, one of the key things here is we need this matplotlib widget to be running so that when we create plots inside of NanoHub, then we'll actually have like interactive plots that way. And if you're running like Jupyter on your own computer, you might need to install like widgets and those kind of things. So if you're trying to use like your own Conda, you might have to say like Conda install image.io ffmpeg, and then there might be some other things that come up. But we'll run this definition. So we're creating a function that when we click on a graph, it's going to start creating it's going to keep adding things to a variable called coords. So it's not returning any information, it's just taking the events of clicking and turning that into something that gets appended onto that thing. And this is originally from Professor Barba at University of Washington. So we got our widgets. We're gonna read our projectile motion movie into here. And when I run this, what happens is it shows me an image and it's telling me on the bottom here, as I keep moving this down, I can see the Y coordinate increasing as my mouse keeps moving down, and that X coordinate is staying mostly the same versus like moving it left and right, X is increasing. Then there's three numbers right next to it. That's actually the red, green, and blue colors. So on these white areas, it's mostly the same. If we go over to brown, now it's mostly red, some green, and a little bit of blue. But anyway, just more information than you needed, but just understanding how an image actually works. So up here, this is like coordinate 0, 0. And then down here is going to be for this 1200 by 716. I forget how big these images end up being. So what I want in this the first time that I load this, when I said coords equals brackets, I create an empty list of coordinates, and every click, so I'm clicking right here on each of these black lines, and all I care about is the Y coordinate. So even if I move over here, that's okay. And it seems like nothing happened, but whenever I come down here and look at the actual coords, I can see I was going down along that 320 pixel line, and then I moved over to the 430 pixel line, and I started at 113, then 166, then 220, 272. So roughly I was moving like 50 pixels per step. So that's my coordinates. One way, so if you're doing this and you want to like save your work, I could say coords equals that, so that next time I jump back in, even if I restart the kernel, I have that original like clicking, like the things that I had clicked on for the gap lines method. And those Y lines, again, that's the only thing that I really care about. I want the mean value. And like I said, it was somewhere around 50 pixels, and it's 53.1 pixels. So coming back up to this image, every time I move down by 52 pixels, In the picture, it's 52 pixels, but in the actual measurements, every 52 is 10 centimeters. So now I've got a direct conversion between the number of pixels that I move and the actual centimeters of motion. So I have like X, Y coordinates that I can track as a function of time. So now I'm going to run this thing again where I can change the frame counter. And let's move on to like frame 53 where it starts moving. And I gotta zoom out a little bit so I can see the frame counter. And I'm clicking on each frame, I'm grabbing the center of that ball. And I skipped over that frame 52. You can leave it in if you want. So keep going. And again, every click is appending a value into that variable called coords. And if you're watching a recording of this rather than watching it live, you can fast forward, and I'll give you a quick wave when I'm done getting through all these frames of the movie. Or maybe this is the content that you signed up for this class. Like, yes, I can't wait to watch someone watch a movie in slow motion and track a ball as it falls. And maybe one or two more. That was it. Okay, cool. And again, it looks like nothing happened, but that whole time I was adding values to this coords. And remember, 10 centimeters, so 0.1 meters is 0.1 per gap line, so 10 centimeters per 52 pixels. So if I have a measurement that is 320 and 100 pixels, I can convert that by dividing by 52 pixels, multiply by 10 centimeters. Now I have that measurement as a function of like how far away from this 0, 0 is it in centimeters. So if I come down here at like 500, that should be 1 meter away, 10 centimeters, and 200, 0.2 meters. So I'm going to run that. Let's look at the scatter plot. And it looks like a ball that's falling. At least I think it does. There's a little bit of noise here based on how well, if it bothers you, you can, again, you can like copy all this, paste it in here, and let's say I don't like that second point. I could go in there and say like, oh, well, it should be maybe 3 or 4 pixels up. So this 107, maybe I want to make that like a 104. And now it looks a little smoother. But that, again, that's up to you if you want to. And what I get for acceleration in the y direction is 10.4 meters per second squared. It's a little faster than I would expect. Meanwhile, acceleration x direction, negative 0.4. And for the homework, I'm going to, there's a line here to save this into your data folder. So run that. And now I have this, here, if I go to open, it'll bring me into my browser. And come in one folder up, go into data, and now there's a projectile coordinates.npz. And I can load that back into my homework problem and do that first part assignment there. And then there's also like a high resolution data set here. If we look at dots like that, all those are individual dots. Let's look at squares. Yeah, so it's so high resolution that you can barely see what the changes are. Anyway, hopefully that helps in if you were having trouble getting this thing to work. It is working. It's just that it doesn't update. It doesn't tell you like, hey, your coordinates are updated now that you did this. And I think it's helpful to copy this output back into that coord so that the next time I run it, I'm not starting from scratch. But anyway, hope that helps, and I'll see you next time. Oh, and coming back.